Hello everybody, in this video I'm going to show you how to use the last version of Flight Voice Commander and the last features that come with it. So let's get to it. Okay, so we have our flight guide over here, and I have Voice Commander over here, which I'm going to set it to be always on top. I'm using a software called Power Toys. It's from Microsoft, and it comes with this feature that enables any program to be always on top. So it is very useful for this, or if you want to use it with the flight guides themselves. So the first run box, you can find it in every aircraft flight guide, and it comprehends some steps that it would be advisable to do in order to configure the aircraft for the first time. These are things that you would not have to do again every time you used that aircraft. It's just for the first run of that aircraft. So in this case, we are going to skip this and start with our pre-flight. So the first step for our pre-flight now in every flight guide for every aircraft is to fetch the data. What data? This data will be sim brief data and other data regarding some facility information, runway information more specifically regarding your departure and destination runway. This, by the way, is valid only if you use SimBrief flight plans. So as you can see, I have my SimBrief flight plan already generated. So I'm going to use this command, and then you will see that all the SimBrief and facility data is imported as variables that then we can use to execute some commands. So let's do that. Fetch all data. Okay, so as you can see, all the data was successfully fetched, and we can see here that the flight plan that was imported, it's correct. Okay, so by the way, if you want to change, because it's important for SimBrief that you use the right ID for that, you could use this command, which will ask you for your SimBrief ID. Okay, so then you enter your SimBrief ID over there, and you will have it. It will be ready for use, right? Okay, so let's go to the rest of this. Now this on this color that it's called dark teal. So all the elements that have this color on them have to do with some data set or data requests. This means that this will be something related with data that will be shown in this log and that you will be able to use, for example, for setting up the configuration of the airplane. In this case, the first data set will show us the fuel and the payload we have to configure on this aircraft. So let's do that. Data set 1. As you see in this dataset, we have the fuel and the payload. This information has been directly imported from SimBrief. okay, from our SimBrief plan. So now what we're going to do is that we're going to enter in the weight and balance application over here, and we're going to set the fuel, like it says right here, 19,525, and we're going to take a look at this number, right? 19, and I'm not sure yet how to put the exact number in a rapid way, because yeah, you could input the number here, but it will take ages. So I'll just set a 1 point more of fuel than it says over here, and then with the payload, that it's going to be this number over here, that's right, 29,000. So now we are going to set the center of gravity of the aircraft in order to have it just halfway these two limits. And now we are going to close this. The aircraft is filled and with the payload on board, and now we are going to go with the following flow that you should already know, right? Because this was in the previous versions. Pre-flight flow.
Starting pre-flight flow. Pre-flight flow completed.
Okay, so our pre-flight flow is now completed. I want to just say a few things about it that it's different from the previous version. Now this flow checks if the aircraft is connected or not with the ground power supply, meaning if the external power is available or not. This is important in this aircraft because this aircraft cannot start the APU with battery on its own. Okay, you need external power to be able to start the APU. So if the aircraft is not connected, it's the flow itself, it's going to call a command that is going to request for that external power to be available, and it will connect the aircraft to the GPU, and then it will continue with the following commands. Now, the other thing that is important with this 747 is that this plane requires different fuel pump configuration depending on how much fuel it has left, right? Because it has a lot of fuel tanks, and you have to manage during the flight these fuel pumps, the switches of the fuel pumps, to be on or off depending on how much fuel is left. So there's a command, voice command with this aircraft that it's called check the fuel pumps, and if you say that, the virtual pilot, it's going to check how much fuel is remaining on the all of the tanks, and it will set the fuel pump configuration according to that. Okay, so that's about that, and that's it. And the other thing is that now the APU is not started in the pre-flight flow. It's going to be started just before starting the engines. So no worries about that. Now the APU won't be started in this section. Now let's go to the configuration of the FMC. Now this is really a really interesting feature that I was working on, and as you can see now, all these elements, you are going to be able to retrieve them using the dataset commands. So let's do that so you can see how that information looks. Dataset 2. Okay, now as you can see, the oops, sorry. The flight plan has been shown here, and I programmed this in order to show every waypoint and every airway to which these waypoints belong. In this case, we're going to departure from this airport, right? And we're going to take the SID 0.02 that comprehends these two waypoints, and then this airway with these two actually waypoints. This is the top of climb, and just this, or then this other airway with these 2 points, and it will comprehend also the top of descent, then this airway, and then this the star googed 1U, right? And then the destination. So this is very interesting because now if you are not sure if your flight plan misses some of these waypoints, as in this case we're going to have to fill a few of them, now you have the detail on what waypoint we have exactly on our flight path, right? So let's start with that, and then I'll talk about the next things. Okay, so let's get to it. First, in initial reference, right? GPS positioning, and then RTE. Well, we should enter our origin and destination, which we have over there. And now we are going to go to departure arrival and select runway 36L, SID 0.2, and trans in this case is Calot, and then to arrival, and our arrival is going to be on the runway 14, so I will choose some of these ILS approaches, and our star is good 1U, over there, trans Cavoy, okay, it's the only choice. Okay, so now we are going to go to our legs and see what's missing, which is I lost a lot of waypoints, I suppose. So we can check over here, right? We started the runway, then Opono, Calot, then it should be this VOR called TGU, but it jumps to Gugdo, which is over here, right? So all of these we're going to fill it ourselves. So let's start by this TGU VOR, and we have a few options, but we can see over here that's 112.2, which is this one, and then B2X, Tebex, Basem, which one? I guess the first one. We're going to check that later. Ensal, and then Gugdo, and we complete our waypoints missing. Okay, so now we are going to check if how this looks right on the map. Let's hope it looks correct. Yeah, it looks, because when you commit a mistake over here, normally there's like a point that's getting out of the screen, right, like really far away. In this case, it's not like that. It's not the case, so it looks correct. We're going to activate and execute, and we're going to take a look again. Yeah, it looks right. Let's see what's happening here. Okay, here's a bit of something going on over here. Dogdo. Okay, right. There was a discontinuity. Where's Dogdo here? Okay, between the start and the approach. Now it is correct. Okay, now our flight plan is ready and set, and what we're going to do next is to continue our steps within the FMC, which should be now about the winds, right? So we're going to be here, and in VNav we have to go into VNav and the next page, and then press again, meaning 2 times next page, and then forecast, and then we should enter at least 3 winds. Now this is not mandatory, but it could help the computer to calculate the altitude and speed at which you should be in each waypoint in order to not get too high or fast into the approach. So it could be useful. Okay, I advise you to do it, but I guess only if you use SimBrief, because otherwise, yeah, you could go here in windy.com and search the waypoints for yourself, but you're going to be ages gathering that information. But it's up to you. So we're going to introduce here. By the way, these are all this is information that it gets from the flight plan, from the SimBrief flight plan, and it takes every waypoint, and it shows the information here at every descent waypoint with the winds and the altitude of that waypoint. So first we have 34,000 feet, 31/30. I think you should enter the 0, I believe, because otherwise it's not going to get it correctly. And well, we have only 4 spaces here, so we're going to pick now the 22, or yeah, it's okay. 22,800 feet, and wind is 53 at 23 knots. Then these are going to pick. It's a big jump from 23 knots to 13 knots, so I'll pick up that one, because later the computer takes these numbers and interpolates the rest, right? And then this one will be okay, I guess. 0.62 at 10 knots. Okay, that's ready. So now we're going to go into the initial reference again and set our zero fuel weight, which we can auto-populate, and then the reserves, and here we have the reserves information from SimBrief, and our cruise altitude, flight level 340, and then our cost index, which will be 224, and then we're going to thrust limit and takeoff, and we're going to pass to the next page of this first and enter our reference temperature, which is going to be this one. This is a METAR notation. The first one is the temperature, and the second one is the dew point. So it is useful to know if at some places there's going to be maybe fog or visible moisture, you know. But in this case, it should not be that way. The number that we have to take is just this one, the 22. And for wind, this is also METAR notation, which is 04T /08 knots, right? So it's going to be 04T /8 knots. Okay, and then on the previous page, flaps standard 20. The CG, it's auto-populated, and we're going to auto-populate our V speeds, and that's it. Execute, and we are ready with our flight configuration. Now we're going to set, before we forget about it, we're going to set our trim immediately. So this is the stabilizer trim you have to set on the aircraft, and here's the stabilizer trim that you currently have. So we're going to take this number to 5.1. there it is. Now the stabilizer trim is already set, and if you have some ATC third-party program or something, you should make the ATC call for departure clearance, and then set the transponder code. In this case, it's going to be over here, right? And then we're going to we're going to skip all that thing regarding the ATC communication into the autopilot panel itself. So now we're going to have to set our speed of V2 plus 10. V2 is 155, so our speed that we have to set is going to be set speed 165.
Speed set to 165 knots.
Right, okay. So now our runway heading, which will be 36, which is already set, and our selected altitude, which will be the selected altitude at which the ATC clears you. In this case, we're going to use our cruise altitude, which it was going to be, I believe, FL 340, and so let's set that. Set flight level 340.
Altitude set to flight level 340.
Okay, that's ready, and now to engage our flight directors. All these things that have the purple point are not automatically set by any flow, but you can set it by voice command if you want. Now, some of these things, for example, this flight director, sometimes it's just faster to just turn it on yourself and on the LNAV and the VNAV. But if you want to set them by voice command, there's the voice commands. Now let's go to the before start flow. And in this flow, as you can see, we're going to turn on the APU and get the aircraft ready for the starting of the engines. Before start flow. Well, here you can see the stats of the APU rising.
APU ready.
Then it turns off the external power right.
Ready for checklist.
Okay, and I'll just skip this checklist. Nothing has changed regarding the dynamics of how you do the checklist, so for the sake of time I will just skip the checklists in the flight guide. Now you should clear all ground equipment in case there's for example the GPU equipment outside, or the jetway or the stairs or something. In this case, this command only clears the GPU. Okay, it doesn't clear anything else. But you know how to, in the case of this aircraft, you know how to clear the ground equipment if you're familiarized with these aircrafts from Asobo. That you should clear the jetway and everything via the ATC, right? Or if you have some other tool like this pushback tube, which is super useful, you can clear all the services from here. Okay, so now we are going to start the engines. Start engines.
Starting engines. Entry. Engine 3 ready. All 4 engines running.
Okay, so we have our engines ready, and we should have done the pushback. Okay, so we have our engines running, and we had the pushback, and now we're going to go with our after start flow. Notice that within this flow, the engine anti-ice is going to be automatically set. There's now a new command that you can call by saying icing conditions, which is going to analyze the surrounding ambient around you, the surrounding weather around you, and it's going to determine what's the best configuration for the anti-ice at this moment. So as we probably can see that there is no icing conditions, it will probably left the anti-ice at auto, but it will also show some information within the log regarding the icing conditions like temperature and such. This command about the altimeter, right, the barometric reference that you can set over here. In the previous version of FVC, this was done automatically. It was set automatically, just like typing in the keyboard the letter B. But I just changed that so that if you want to set it automatically, you can say this, set local altimeter, but it will only show the information, so you can manually set it over there like a real pilot will do. And okay, that's it. Let's go to the flow. After start flow.
Ready for taxi call.
Okay, so as you can see over here is the information about the icing conditions. In this case, it didn't find icing conditions, so all the anti-icing of the engine was set to auto. And here you have the barometric reference, the local barometric reference, so we can set it up in our aircraft. This is the more precise number, by the way, 29.91 inches, and flaps, right? Flaps 20.
Flaps 20.
Okay, so we are ready for the taxi clearance and the checklist, and we're going to do now the taxi rollout. before takeoff flow.
Ready for checklist.
Okay, so an important change or improvement to this ready for takeoff flow is that now it will continue after the autopilot, and if you have imported a SimBrief plan which holds the transition altitude of the place you are, the algorithm will continue so that it calls out the transition altitude. So you can set the altimeter into standard, and you can also set it by voice command if you wish to, and it will automatically set all the lights for above 10,000 feet AGL. Okay, let's take off. Ready for takeoff.
Ready. $80 knots. Rotate. Positive rate.
Gear up.
Gear up. Acceleration altitude.
Retract flaps.
Flaps retracted.
Engage autopilot. Okay, so now we are in automatic flight. As you see, it says over here the pilot monitoring is now following the altitude in order to call out the transition altitude, which is this one. This value, it takes it from SimBrief, and this value over here, which is the 10,000 feet AGL, it's calculated with the simulation variables. So when we are at 10,000 feet, the lights are going to be automatically switched, and when we're at 14,000 feet, we'll have a message here that will say that we should set the standard barometric reference.
Ten 10,000 feet above ground. Switching lights.
As you see, the virtual pilot has changed the lights on its own, and ready for takeoff flow actually is still running until the transition altitude.
Transition altitude. Set the standard barometric reference.
Well, we have over here a message about the standard barometric reference, and now the ready for takeoff flow is over. So we can do it by saying this, or we can do it manually. So let's do it by voice command this time. Set standard altimeter. Yeah. Okay, so what comes next is the cruise. So during cruise we should keep an eye on these things, especially in this plane. This fuel tank progression. Check the fuel pumps would be the voice command that you can use if some alerts about the fuel pumps arise over here. Normally when the plane gets the fuel left gets to a state where you should change the fuel pump configuration, then it will show some warnings over here, so you will know. And well, the pressurization, the aircraft stays pressurized, the flight plan to be aware of where it is the TOD over here. It is in our case the top of descent, and set in our FMC our approach and start if we haven't yet. And this is very important to set the altitude, the altitude to the procedure that this information should come from the ATC at which altitude you're cleared to descend to, and that altitude you should set it over here before the top of descent. Okay, so now we are at our cruising altitude, and we're going to soon start the descent, but first we're going to set over here our altitude at which we're going to go into. Now we're going to go into an ILS approach. So normally for an ILS approach, something like 3,000 feet above ground level should be enough in order to capture the glide slope. So I want to know at which altitude it's our destination. So there's a few ways in which we can get that information fast. One is the flight plan that we saw earlier. Show me the flight plan. So as you can see, over here we have the altitude of the destination, 59 feet. The other way is to get the information regarding the specific runway, which can be like this. Show me the destination data. So over here we have the elevation also, 59 feet. So if we descend into set altitude, 3000.
Altitude set at 14,061.9990234,375 feet.
Okay, that's an interesting bug. I will look into that to see what was the problem, but we have our altitude set, the right altitude, and it should start descending. Well, as we see, it didn't descend on its own, so we can just push the altitude button and it will go down. So now we're going to go with our starting descent flow, which is going to also call out the transition level, just as ready for takeoff flow called the transition altitude. Starting descent. Okay, so let's go into our FMC. Initial reference. Approach. We're going to select flaps 30 and to check our ILS frequency, which should be 109.9, which is correct, and the auto brake. And the radio minimums. I'm not going to look at the charts right now, so I'm going to just set radio minimums. Here you can see them. It's a bit complicated sometimes to get fast enough to the amount of altitude you want with this knob. Sometimes it's a bit too sensitive, and I wanted to find some way to set this via voice command, but there's no simulation variables that could be used, or key events that could be used to set this knob. So for the time being, we are just able to set it manual, which is not a big problem, since a lot of the other stuff that could take a lot of time from us, it's already made by the virtual copilot. So now we are going into our approach. So the next thing we should see is over here the transition level, when the copilot is going to remind us to set the destination barometric reference over here, and it's going to tell us what that barometric reference is by a message in the log. Okay, so now we are close to the transition level, so let's see what happens.
Transition level.
Okay, so here it gives us the configuration for the altimeter, and now we set it correctly, and now at 10,000 feet the copilot is going to change the external lighting and turn on all these lights. Okay, so now we're getting close to 10,000 feet. Let's see how the copilot changes these lights.
10,000 feet above ground. Switching lights.
Awesome. Okay, so now we should put our attention into our approach. Flaps 1.
Flaps 1.
Now we're going to start reducing our speed in order to get into the appropriate altitude so we can catch the glide slope. Flaps 5.
Flaps 5.
Flaps 20.
Flaps 20.
Flaps 30.
Flaps 30.
Gear down.
Gear down.
arm spoilers. As you can see these items over here, this is a nice order to do them, but it depends on the situation. Sometimes you will drop the gear earlier, or arm the flaps later, or setting the approach mode later. I have to set it later because we're not yet in the path. But it's no problem. It can be done in various ways. So now I'm going to set our approach mode. Well, as you can see, as you can see, the path took us too high for the glide slope. That's curious. The approach path should set you to an appropriate height to get the glide slope. But, well, we're going to log on it anyways, I guess. There it is. Okay, retracting. You can use the speed brakes with voice commands also. It is actually very useful when you can't use your focusing on your joystick and you can't use the mouse. Okay, so we're at the glide slope. I'll set the altitude for, in case if I go around. I believe it's everything correctly set. Okay, so that was a successful landing, and in the case of the go around you can do this, and after landing we go for the landing flow. Landing flow.
Landing flow.
Which is going to start up the APU
Flaps
and
retracted.
check the anti-ice.
APU ready. Landing flow completed.
And then shut down aircraft.
Shutting down aircraft.
You can see I also get rid
Engine
of
1 shutting
the
down.
checklists
Engine
that
2
were
shutting down.
over here.
Engine 3 shutting down. Engine 4 shutting down. Ready for disembarking.
I thought of them like a bit useless being at this stage of the flight, so in order to make it a bit more time efficient, I just left the flows. So now ready for disembarking mean you can disembark and for example, right, get the jetway or whatever you want, right? And then if you want to, this is useful for if you want to take off again later. This shutdown aircraft leaves the aircraft at the same state at which the aircraft was left after you did the pre-flight flow, right? So it is useful if you want to then start again another flight. Just act like you came just from the pre-flight flow, and it's all going to be working pretty nice. And if you want to just shut down the aircraft, you can say secure aircraft.
Securing aircraft.
Okay, so that's it. I hope you liked it, and if you have any questions about it, you can get support for FVC in the Discord. I will leave the links to the Discord and all the relevant information for
Aircraft
this
secured.
for this add-on. So that's it. Bye bye.